Hello friends, welcome to my YouTube channel. Today we will learn physics. We will talk about the gravitational field. I hope you enjoy it. The gravitational field. We have been taught that Isaac Newton was hit on the head by a falling apple while resting under a tree. This event inspired him to imagine that somehow all the bodies in the universe are attracted to each other, just as the apple was drawn to the earth. In 1686, Isaac Newton published his work on the law of gravity. It tells us that every particle in the universe attracts another particle with a force that is directly proportional to the product of its masses, and inversely proportional to the square of the distance between them. Let's see if two particles have masses m1, m2 and are separated by a distance are the magnitude of this gravitational force is as seen in the formula Fg equals gm1 m2, r2. The g of the equation is the universal gravitational constant, which has been experimentally measured. Its value in units of the international system is 6,672 times 10⁻11 newtons per square meter over square kilogram. When the value of g was first calculated in the 18th century, people around the world were thrilled. The newspapers announced the experiment as the one that managed to measure the mass of the planet Earth. The calculation was made as follows. It is known that the force exerted by the planet Earth on a mass of 1 kilogram on its surface is 9.8 Newton, the distance between the centers of mass. The body of a kilogram and the Earth is the radius of the Earth, that is equivalent to 6.4 times 10 to 6 meters. The radius of the mass of a kilogram is not taken into account it is very small compared to the radius of the Earth, thus replacing these values together with that of the universal constant of gravitation g. In the equation of the force of gravity being m1 of the mass of the Earth and m2 of a kilogram, we have to by solving the operation and solving the unknown m1. The mass of the Earth is 6 times 10 to 24 kilograms. Newton's stupendous formula gives the mass of the entire planet, including oceans, mountains and parts of the subsoil still to be discovered. A fact important is that the gravitational force exerted by a finely sized, symmetrically spherical mass distribution on a particle outside the sphere is the same as if the entire mass of the sphere were concentrated at its center. Don't forget to follow us on our social networks on Facebook and YouTube. Until next time.